Okay, topic 9, differentiation. This is 9.1, derivative of a function. Activity 1 of 5. Objective for this lecture: at the end of the lesson, students are able to find the derivative of a function fx using the first principle. This is the first principle. And discuss the differentiability of a function at a x is equal to a. Derivative of a function. The derivative of a function y equals f of x with respect to x can be denoted as, okay, you can write dy dx or d dx, d of fx dx, or y prime or f prime of x. So here dy dxy is a function y is equal to x squared plus 1, let's say, or fx is equal to x squared plus 1. Okay, or you can write y prime. Y prime equal to dy dx. Find derivative by using the first principle. Okay, the first principle of a function with respect to x is given by f prime of x equals limit, okay, f of x plus h minus f of x over h as h approaches 0. Okay, this one using the first principle. Example: find the derivative of the following functions with respect to x using the first principle. You have to use first principle. If you find directly, let's say f prime of x is equal to x, so you not follow this one. Okay. As first is this formula, f prime of x is given this. So now you need to find fx plus h given fx is equal to x squared. So now x come x plus h, x plus h. Okay, then substitute in the formula. F prime of x is equal to limit h approaches 0. This is h, not x. F, okay, this one is f of x plus h. Okay, then substitute x plus h squared, okay, minus fx. This is fx. Okay, x squared over h. Then expand and simplify. Limit h approaches 0. X squared plus 2x h plus h squared minus x squared over h. And simplify. Okay, this one can be cancelled. And this is h. 1, 2, and then you can factorize. Okay, factorize this 2x plus h over h. So this one can be cancelled because of h over h. Okay, and then limit h approaches 0, 2x plus h. Then substitute the value, and then substitute the value h at h equal to 0. So it's equal to 2x plus 0 and is equal to 2x. So that is the answer. Okay. Okay, for B, f of x equals third x minus 1. So we need to find this one, f of x plus. Now this x, we have to substitute x plus h, okay, x plus h minus 1 under, okay, cert. Then using this formula, first principle, f prime of x is equal to limit, this one h is not x, h approaches 0, and f, if we take this one first, okay, f of x plus h substitute cert x plus h minus 1 minus over h. Okay, so minus this one, f of x cert x minus 1. Let's say if you substitute h here, okay, the value x plus 0, 0 minus 1, so x minus 1 minus x minus 1 over 0. This is 0 over 0. Indeterminate form. Okay, and this is cert over polynomial. You have to multiply with the conjugate. Okay, and limit cert x plus h minus 1 minus cert x minus 1 over h, then times its conjugate. Okay, this one conjugate, this one is conjugate, and then cert x plus h minus 1 plus, okay, x minus 1 over x plus h minus 1 plus this one. Okay, and do in the big bracket. Okay, okay, then this one. Okay, then next is, okay, simplify this one, cert this term times this, get x plus h minus 1, then minus this term, multiply this term, negative x minus 1, okay, over h. This one just rewrite, okay, you don't have to expand x minus 1, and I simplify, limit h approaches 0, and this one is x minus x cancel, negative 1 minus minus, so positive cancel. Now that's what is, okay, here is only h, okay, just rewrite h over h times cert x plus h minus 1 plus cert x minus 1, then this one can be cancelled. Okay, next step, just rewrite here. Okay, okay, limit h approaches 0, 1 over cert x plus h minus 1 plus cert x plus minus 1. Substitute h 0, and then answer is x minus 1 plus cert x minus 1. Assume this one is y plus y, so you get 1 over 2y, 1 over 2 cert x minus 1. So settle. Okay, we can compare this one. Then you get, and then substitute 0, then this is the answer. Okay, settle for this part. Okay, the next is differentiability of a function. A function is f is differentiable at x is equal to a if f prime of a at point, value a limit f of x minus f of a over x minus a, this is x as approaches a exists. Okay, that is limit on x approaches a from right is equal to limit x approaches a from left. Okay, so you have to find this one. When equal, we can say that a function f is differentiable at x is equal to a. Okay? If a function f is differentiable at x is equal to a, then f is continuous at x is equal to a. This one first. Then we can conclude f is continuous. Okay? Okay? Differentiable first, then continuous. Example 2. Given f of x is y function, is f differentiable at x is equal to 0? And remember, f of 0 you need to use the f of x when x is equal to function when x is equal to 0. This is the one. Okay, so let's discuss example 2. First thing, change to number line. Okay, x less than 0. Function is at 2x plus 3. When x is more or equal to 0, the function is x squared plus 3. The first step, find when f of 0. When f of 0 lies here, okay, then circle, we choose this function x squared plus 3. Substitute 0, answer is 3. Okay, this is f of 0. Okay, then the formula for the first principle at the point is limit f of x minus f of a as x approaches a over x minus a. Okay, this one. Okay, this is the formula. We need to find limit x approaches 0 from left and also from right. Okay, limit x approaches 0 from left. Okay, limit x approaches 0 from right. So fx for this one 0 from left here. Okay, lies here. So we choose this function 2x plus 3. Okay, for 0 on the right here, we choose this function x squared plus 3 minus f of 0. Okay, 3 minus 3 over x minus 0. X minus 0. Okay, simplify. Is equal to limit x approaches 0 from left. Okay, 2x over x. So, and then simplify and substitute. Okay, for this one, limit x approaches 0 from right. Cancel 3. Okay, x squared over x. Okay, and then limit x approaches 0 from right. Okay, x. Then substitute 0. Okay, and then you can conclude that, okay, since limit fx minus f of 0 as x approaches 0 from left, which is x minus 0, not equal, limit fx minus f of 0 x minus 0 as x approaches 0 from right. And then we can conclude that therefore f prime of 0 does not exist. Does not exist. Okay, does not exist. Okay, therefore f is not, okay, f is not differentiable at x is equal to 0. Okay, why? Because of limit does not exist. Prime of 0 does not exist. Okay, means that does not, f is not differentiable at x is equal to 0. Example 3, a function f is defined by this function. Determine the value of k if f is differentiable for all real values. Prima, f is differentiable for all real values implies that f is differentiable at x is equal to 1. And therefore, we use this first principle and limit as approaches 1 from left is equal to limit as approaches 1 from right. We use this one, then find the value of k. Okay. Change to another line. Less or equal, this one is x squared minus 1. More than k times x minus 1. Okay. And then substitute f of 1. F of 1 lies here. Okay, means this function x squared minus 1. 1 minus 1 is equal to 0. And find limit. Limit x approaches 1 from left and also limit x approaches 1 from right. Okay. And x approaches 1 from left, here left, this one, x squared minus 1 the function. Okay. For x approaches 1 from right, here, it is function k x minus 1. So, minus f of 1, 0 over x minus 1. Minus 0 over x minus 1. Okay. And simplify. 1 is equal to x minus 1 factorize. Factorize. Then this one equal, can be cancelled. So this one, limit x approaches 1 from left, x plus 1, substitute 1, 1 plus 1 is equal to 2. Settle this part. And for this part, okay, and then this one equal, we cancel, and then you get limit x approaches 1 from right, k constant, so it's equal to k. And then since given that, or given f is differentiable at x is equal to 1 implies that limit x approaches 1 from left 1 over x minus 1 is equal to limit x approaches 1 from right fx minus f of 1 over. Okay, and then this one is equal to, on the left hand side is equal to 2, and then on the right hand side okay, is equal to k. So this one is 2, this is k. Therefore k is equal to 2. Okay, for this example, conclusion. Derivative of a function f using first principle. Okay. Differentiability of a function at x is equal to a means if a function f is differentiable at x is equal to x naught or a, then f is continuous at x is equal to a or x naught. Okay. Exercise. By using the first principle, find f prime of x for derivative of the following function. So you need to use first principle. Okay. You cannot say that f prime of x is equal to 3. No, you need to use the first principle. And this is the solution. Okay, this first principle, you need to find f of x plus h. Then substitute this formula and simplify. then get the answer 3. So simple. For B, okay, and then find the f of x plus h, and this one. Okay, then substitute the formula. Substitute over h. Okay, you can write like this, 1 over h. Then equate the denominator. Then simplify. Here, same h, cancel. Then substitute 0. So the answer is, okay, settle for lecture 1.